The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back.
Alam nyo na kung paano nag-work yung solar panel and kung saan siya. Ngayon, hindi ko lang sure kung nag-work ba siya sa phone or pwede ba natin siya i-connect sa phone. Tanong ka pa ba?
So, when was the first solar panel invented and how it evolves?
Kung paano siya nag-invent and kung paano siya nag-evolve sa industriya, hindi ko talaga sure kung may contribute ako dyan. Pero may kilala ako na mas makapag-explain. Hanapin natin. Ay, ito pala! Hindi natin kailangan hanapin. Tol, may tanong kasi siya. Hindi ko ma-explain eh. Kaya... Tol, ano ba yan?
When was the first solar panel invented and how it evolves?
Sige. Dali lang yan. Sige, ganito yan. In theory, natuto natin gamitin ng solar power gamit simula noong 17th century BC. Habang sa history naman sinasabi na natutunan natin gamitin ng daylight para makapagsunod tayo ng bagay gamit ang magnifying glass materials. Yun, so simula doon, nagkaroon na tayo ng evolve.
The first huge step in solar panel technology came when Alexander Becquerel observed the photovoltaic effect in 1839, which occurs when a material produces electric current when exposed to light. It was not until 1888 that the first solar cell was actually built by Alexander Stoletov. His cell was based on the discovery of the outer photoelectric effect, which caused electrons to be emitted when energy was absorbed. Solar panel technology did not become well known until Albert Einstein published a paper in 1904 on the photoelectric effect. Using technology from Einstein and earlier scientists, Bell Laboratories produced the first modern photovoltaic cell in 1954. The cell was not very effective, costing $250 to produce 1 watt of electricity. The same wattage could be produced for $2 to $3 in a coal plant. This set the stage for more effective uses, including solar cells being used in 1967 for the first time on a manned spacecraft, the Soyuz 1. Even with the more efficient cell created by Hoffman Electronics, for years, the only viable use of solar cells remained in spaceflight. In 1973, solar cells were fitted on Skylab, a US space station that orbited the Earth in 1979. The solar cells were so important to the operation of Skylab that the space station only lasted 6 years due to the cells being damaged during launch. During the 1970s, solar panels became more efficient in part due to the work of the Solar Power Corporation. By 1977, solar panels have advanced so far that the President Jimmy Carter had them installed at the White House and even provided incentives for solar power. The advances of the 60s and 70s drove the price per watt of solar energy from $100 down to around $20. This increased photovoltaic production, which hit 21.3 megawatts in 1983. The use of solar panels continues to increase. President George H.W. Bush created the National Renewable Energy Laboratory in 1991, which continued to work with solar energy. This continued interest led photovoltaic production to hit 1,000 megawatts in 1999. Since that time, President Barack Obama has had more solar panels installed at the White House, increasing public knowledge of the technology. While solar panels have come a long way over nearly 2 centuries, the basic technology necessary is almost identical to what it was in the 1830s. With solar energy production increasing at such a large rate over this period of time, many people remain hopeful that the solar power may very well help run the world one day.
Alright. May gusto ko pa bang idagdag? Wala na. Pero ako may tatanong pa ako. How does it harm the environment and why do we need solar panel?
Pros and cons,
Oo, yun.
hindi ako sure eh. Pero hindi ko alam kung meron ako mahanap na makakatulong sa'yo. Siguro ka. Oh, ito ba eh? Sakto na laptop. Higa. Ay! Ano yan? Ano yan? May tatanong lang daw sila about solar panel. Baka matulungan mo sila. Ano ba yun? Solar panel! Ano? Ano yun? Yan.
Oo. Sige, salamat.
Yan ah.
Ito kasi tol, why do we need solar panels and how does it harm the environment?
Yun lang pala eh. Meron akong reasons kung bakit ginagamit ng solar panel. Andito yun.
Ganun pala yun. So, may dadagdag ka pa ba?
Oh, wala na. Ay! Wait lang! Oh,
Ano?
meron pa pala.
Oh.
Meron akong tatlong reason naman kung bakit harmful siya sa environment.
Oh, sige.
Ano ito yun?
Oh. Alright. Oh, sige. Wala na dadagdag.
Wala na, ikaw. Meron pa ba?
Sige. Ito, how much do you think will be the cost in having a solar panel and before and the present time?
Yun na. Yun na tanong mo?
Oh.
Sige. Punta tayo dyan. CR yan. Anong tanong mo ulit?
Ito kasi tol, how much do you think will be the cost of having a solar panel?
Ayun ang karin.
Uy, ano yun?
May tinatanong sa'yo?
Ano ba yun?
Ito kasi tol, how much do you think will be the cost of having a solar panel before and the present time?
Cost. Siyempre, kapag ginumpare mo yung noon sa ngayon, siyempre may mas mahal naman talaga yung mga presyo ngayon. Kasi, yung kagaya ng sa cellphone, yung iPhone 4 naging iPhone 5. Yung iPhone 4 ba, mas mataas yung presyo kasi sa iPhone 5? Siyempre hindi. Kasi, ano yung sinasabi nila? Kumbaga, nag-upgrade yung materials, nag-upgrade yung gamit, nag-upgrade kung paano gagamitin. Di ba? So, kung sa materials, yung materials mismo, yung nagpapamahal dun sa solar panel. Kaya, noon, syempre, makagawa ka nga ng sarili mo eh. Kung may knowledge ka, gumawa. Pero kung ikaw compare mo talaga noon, mas mura talaga siya. Kasi nga, out of materials. Tapos kung materials lang naman yung pag-uusapan natin, meron akong kanila, tapos tawagan natin. Halika. Lutol, Kenneth, ano kasi nagtatanong sa akin dito about dun sa materials ng solar panel? Pwede mo ba i-explain sa kanya? Ito, kausapin mo.
Hello? Materials lang ba? Ito yun. Crystalline silicon. Ito yung common material para sa solar cell. Kilala rin sa tawag na solar grade silicon. Pangalawa, monocrystalline silicon. Gawa sa single crystalline silicon, ito din ang pinaka-efficient and more expensive than most other types of cell. Pangatlo ay polycrystalline silicon o multicrystalline silicon cell. gawa sa large block na molten silicon, carefully cooled and solidified. Ito ay mas mura pero less efficient kumpara sa monocrystalline silicon. Pang-apat ay ribbon silicon. Isang uri ng polycrystalline silicon. Ito ay nabuo sa pamamagitan ng thin films mula sa molten silicon. Pang-lima ay monolite multisilicon. Tinatawag din na cast mono. Ang disenyo nito ay gumagamit ng polycrystalline casting chamber with small seed of monomaterial. Pang-anim ay thin film. Itong thin film ay nagbabawas ng active material sa isang cell. Mas mabigat din ito sa crystalline silicon panel. Pang-pito ay cadmium telluride. Ito ay highly toxic at ang supply ay limited lamang. Pang-walo ay copper indium gallium selenide. Ito ang pinaka-efficient sa lahat ng thin film materials. Pang-siyam ay silicon thin film. Ito ay mainly deposited ng chemical vapor deposition galing sa slane gas at hydrogen gas. Panghuli ay gallium arsenide thin film. Ito pre ay semiconductor material na ginagamit din sa single crystalline thin film. Yan yung mga karaniwang materials ng solar panel. Nagets mo ba pre?
No bro, okay na. Naintindihan na namin. Sige, salamat ha. May tanong ka pa ba?
Meron pa. Can we make solar panels out of basic materials?
Pwede naman. Kaya lang kung gusto mo ba ng further explanation, hindi kasi ako masyadong ma-knowledge doon. Eto, may mga kaibigan ako dito. Mas alam yata nila.
Sino yan?
Pre! May tinatanong to. Wag daw sa pwede daw ba gamitin? Ano yung tanong mo?
Hindi ko patapos yun.
Yung tanong ko po, can we make solar panels out of basic materials?
Alright. Sa pagkakaalam ko, pwede tayo mag-improvise ng mga solar panels kasi konti lang naman yung materials na ginagamit dyan, saka hindi naman ganun kadami. Pero pwede natin siya gamitin, pero hindi ganun ka-efficient tulad ng manufactured ng solar panels. May mga example ako yan eh. So, ang paggawa ng improvised solar panel ay kailangan mo lang ng coil, salamin, at iikot mo to dun sa salamin. Tapos, i-connect mo siya sa device. Tapos, pwede mo na siyang gamitin. Pero, wala siyang control sa wattage at sa current na pinapasok. Kaya mo siya kailangan ilagyan pa ng mga diodes na or resistors na pwede mag-convert nun sa pang phone at pang bahay. So ayun, nakita nyo na kung paano mag-improvise sa solar panels. Oh, dumating na pala eh.
Magaling.
Magaling. Bakit siya? Siya ka? Oo. Ito na naman siya? Oo, kanina pa nga naman. Tinanong na rin ako.
Sino naman na rin?
Ano? May tanong ka ba? May tanong ka ba?
Sa akin, may tanong ka ba?
Okay ka na? Okay na?
Okay na.